A quick review from yesterday, and then just a few more things from today. Did I make it clear enough to you yesterday how important being able to go from exponential form to logarithmic form was, and being able to go from logarithmic form to exponential form? Did I make that clear about how important that was? Okay, good. So if I give this equation to you in exponential form, can you write it in logarithmic form for me, please? Do it. Of 49 equals 2, right? Log base 7 of 49 equals 2. Do you see where everything went? Make sure he sees where everything went. You see where everything went? Okay. Can we go backwards? So if I say log base 3 of 7 equals x, equals 7, right? Okay. So it seems like you have a pretty good hand on that, right? So what if I ask you then, what if I say log base 9 of 81? Please evaluate that. So your first inclination is to try to write it in exponential form? That's great. Okay? So if I write this in exponential form, it's 9 to what power? Something we don't know, because that's what we're trying to figure out, right? Equals something. So we can call it x, that's fine. Equals what? Is that something you can figure out? Is that something you actually already know? What does x equal then? 2, right? What if it was not something you already knew? All the ones that we're dealing with today, you can take your calculator and say 9 to the first power, 9 to the second power, 9 to the third power, 9 to the fourth power, and figure out what it is. Okay? Keep in mind, actually, let me just see if I can I just see if I can trick you real quick? Is that okay? Okay. Log base 3 of 1 over 81. Evaluate that. One over 81, right? Okay, so what do you think it is? You know it's not 1. You know it's not 2. Three to what power is going to give you 1 over 81? Well, think about this for me for just a second. 3 to what power would give you 81? 4, right? What is going to make it be 1 over 81? That's a good guess. 1/4 is a good guess, but that's something different going on there, right? What makes it reflect like that? A negative. Next, -4. Okay? Does that make sense? Okay. Let's see if I can figure out a really, really, really hard one. What about this? Log base 2/5 of 1. So what are you going to write first? 2/5 to the x power equals 1. Melody thinks she knows the answer. Why do you think that's the answer? Anything to the power of 0 is 1. It doesn't matter what this base is. If the 1 is right here in the argument, so it's what equals in exponential form, x is 0. What do I want to give you now? Oh, I'll give you one of these now. The directions this time are simplify. You just want to start erasing stuff? Okay, that's a bad idea. Okay, but good try. Could we write it in exponential form? If we wrote it in exponential form, it would be 4 to some power we don't know equals the argument, which is 4x. But remember, this is the thing we didn't know, right? So what is the thing that we didn't know equal to? So it's just x. Seven to the something we don't know. I'm going to go ahead and put a question mark this time. Make it a little bit less confusing. Equals the argument. What is the thing we don't know? 3x. Anybody see any sort of thing that could help us do this faster? I would be careful about doing it in your calculator, because sometimes your calculator has a variable stored or a value stored for a variable, and it's not going to just tell you x. It didn't, did it? Okay. What's the base of this log? What's the base of this exponent? 7, and what's the answer? What's the base of this log and the base of this exponent? And what's the answer? So if I tell you this, log base 5 of 5 to the 7x, what's the answer? Why? What's they? The bases are the same, right? If the base is the same as this base, what's the answer? The exponent. Okay? What's left? It's like I already took care of all that stuff with the two bases. So 7x is all that's left. So 7x is my answer. Can I throw you a curveball? Okay. That's not really a curveball, is it? What's the rule that we just said for this one right here? If the bases are the same, what's the answer? What's left? Aren't these bases the same? It's just in different places, but the bases are still the same. What's the answer? Yes, we could write it in exponential form. I'm not saying we couldn't. I'm saying it's a little shorter to do it this way if you understand the fact that the bases are the same, so the answer is just going to be what's left. What we're doing in the background is writing it in exponential form. Okay? Think about it. Think even this one, right? If we wrote this one in exponential form, it's already in exponential form, so we'd be writing in a logarithmic form, right? So I would write log base 4 of what? Something I don't know equals log base 4 of 3x, because that's the exponent. So what does this something I don't know have to equal? 3x. Does that make sense? As long as you understand what's happening in the background, I don't mind if you go from here to here. Is that fair? Just know that we're writing it in the other form inside of our heads and knowing what's going on. Questions? How comfortable do you feel going from exponential form to logarithmic form? How comfortable do you feel going from logarithmic form to exponential form? How do you feel about evaluating logarithms when this is all you're given? Because you just write it in exponential form, right? And then figure out what's not there. And then how confident do you feel if I say simplify when it's something like this? You want to practice some? You mean yes? Yeah.